Knowing when to change the inequality sign and why is a skill you will need for the math portion of the ACT. We will do this by reviewing how to solve inequality statements in the classroom. Okay, let's talk about solving inequality statements. A couple things you need to know. You're going to solve inequalities just like an equation, but there are a few exceptions. Like one thing, you want the variable on the left side. It just makes it easier to read. A couple other things you need to know is when you multiply or divide by a negative number, you have to change that inequality sign. It goes from a less than to a greater than or vice versa. Let me explain to you why that's done, because a lot of people don't understand that, and if you understand, I think you'll remember what the rule is. If we take a number line, put two numbers on there, and if you were to compare -3 and 1 in an inequality statement, you'd have -3 is less than 1. That makes sense. Well, what would happen to those numbers if we were to divide or multiply them by, say, an easy number like -1? Let's divide by -1. You would get +3 and -1 on the right. If you were to multiply by -1, you would get the same result. Well, would the inequality stay the same? No, it goes the other way because a +3 is greater than a -1. So I just wanted you to have an understanding of why, because a lot of people say I've never been told, they just memorize the rule. Well, here's why, just so you can see it in terms of number sense. Another reason why you would want to change the inequality is if you would have your variables maybe on the right side of the equation and just the numbers on the left, and you want to swap sides, you want to switch sides, you switch the inequality also. Because like I said earlier, you want the variable on the left side. It makes the inequality statement much easier to read because if you don't have the variable on the left side, you've got to read things backwards, which is kind of confusing and difficult to do. Now let's take a look at a few examples. 1, 2x plus 3 is greater than or equal to 4x plus 11. Now, like I said, we want the variables on the left side, so let's start there. I'm going to leave the 2x there. I'm going to subtract 4x from both sides, so it's going to give us a 4x here when you subtract 4x from both sides. And then also in the same step, you can subtract 3 from both sides, giving you 11 minus 3. I'm trying to do it in one step. It makes it a little bit more neater and organized, so you just have to think of it mentally. Now let's do 2x minus 4x is -2x, greater than or equal to 11 minus 3 is 8. Now to solve for x, we're going to divide both sides by -2. So that's going to give us x. On the right side, it's going to give us -4. Now, what do? We just divided by a negative. So we need to make sure we switch this inequality sign. That means that make it point the other way. And that would be your solution. Graphically, what does it look like graphically? It says you might have to look at a graphic solution. They might just give you x less than or equal to -4 as one of your choices. They might give you a number line solution. So you need to know how to do that. So let me put -4 here and 0 on the number line. If that line, that inequality has a line underneath it, you are going to include the number. That means inclusive, so that means equals. So it's kind of like it would be a solid dot at -4. And if x is on the left side, all you have to do is look which way is that arrow pointing. That tells you all the numbers to the left of that -4 would be a solution to this system, to this equation. Sorry, inequality. Let's try another one. Let's look. There's a number of different situations you can have with these. 2 times the quantity, 4 plus 3x, greater than 3x minus 1. Okay, first thing you got to do, you'll notice there's a set of parentheses and there's a number out front of it. You're going to have to distribute that number of 2. So we're going to get 8 plus 6x greater than 3x minus 1. Now, variables I want on the left side. So I'm going to take and I'm going to subtract 3x from both sides. So we're going to get 6x minus 3x greater than, and then that means we would have to subtract 8 from both sides. So you're going to have -1 minus 8. This is going to give you 3x on the left side greater than -9. Now to solve for x, you're going to divide both sides by 3. That would give you x is greater than negative 3. Now the reason I showed you this is because a lot of students think, okay, you got a negative number for a part of your solution. That means switch the inequality sign. No. Did we divide by a negative? No, we divided by a positive 3. Leave that inequality sign alone. And if you went to graph it, here's negative 3, here's 0. Now since the inequality doesn't have a line underneath it, you would have an open circle and you shade whatever that way that arrow is pointing, and it's going to the right. Let's take a look at one more scenario. Okay, the last one. 16 less than or equal to. The quantity 2x plus 6. What do you notice? You have the variable on the right side, which we don't want. We want the variable to be on the left side. So here's a situation where we might switch the inequality because I'm going to switch sides. I'm going to flop sides. What does that mean? I'm going to put the 2x plus 6 over here. And I'm going to put the 16 on the other side. It's kind of like if we took a look, we had the arrow here, and we flipped sides, we would point the arrow the other way. That's kind of a silly way to know why you do it, but it works. That's kind of like a reason why. And we'll check our answer when we're done. So I'll prove to you our answer is right. So let's start solving, getting x by itself. So we're going to subtract 6 from both sides. 2x greater than or equal to. That would be 10. Divide both sides by 2. You would get x is greater than or equal to 5. Well, I'm not sure if I was allowed to switch that inequality sign, so I'm a little shaky about that. So let's draw our solution. Here's 0. Here's 5. We would put a solid down there because we have a line underneath, that means we include the 5. And by the way we have it right now, we should be shading everything to the right. Now, if you're not sure if you did the switching of that sign correctly, it's simple. Go back and pick a point to the right of 5. Pick a number. Let's do 10. Would 10 make this inequality happy? Put 10 in here. Go to the very original. Don't trust any. You could have made mistakes here, so let's go back to the very original. Put 10 where the x is. 2 times 10, 20. Plus 6, 26. So you look like, here's what it would be. 16 is less than or equal to 26. Is that a true statement? Yes, it is. It would tell you you did switch inequality correctly.